Question number 1. It says solve the system of equations. You may either use substitution or elimination. If I'm looking at this first one, you know, I could go either way, but I think I'm going to go elimination. So let me just zoom this out a little bit here. I'm going to go elimination. I'm going to multiply the top equation through by a positive 4. When I do that, this equation becomes 12x plus 4y equals that 26, and 26 is, what is that, 52? It equals 52. And then below that, I'm just going to rewrite this equation unchanged. So I've got 2x minus 4y, and that equals positive 18. The reason why I multiplied the top one by 4 was I wanted to get my y coefficients to be opposite. And you can see now I have a positive 4y and a negative 4y. And that's beautiful because when I add these together, I get 14 x's. I get absolutely no y's. And when I add the 52 and 18, I should get, I believe, 70. Is that right? Yeah, I get 70. Now, 70 divided by 14, I don't think it's as... Oh, that's beautiful. So x is equal to 5. Now that I know x is 5, I got to plug that into one of the two equations to figure out what y is. I'm going to use this equation unchanged. So I'll say 3 times the x that I just found plus y equals 13. Y equals 13 minus 15. So was y negative 2?
Yeah.
Okay, so I write this as 5 comma negative 2. There's my solution, right? The xy ordered pair. The second one we had, this is a great... Yes, go ahead. Okay. Next equation, I think, is a great candidate for substitution. The reason why I choose to substitute is this thing I've just placed in parentheses is equivalent to y. So I'm going to take this x minus 3 and substitute it into the second equation. So the second equation becomes 4 x's plus a y. Playing the part of y is x minus 3, and that equals 32. So, you know, distribute in, get rid of the parentheses. I have 5x minus 3 equals 32. Therefore, 5x equals, what, 35? And x equals 7? Oh, good, I can put 7. Now that I know that x is 7, I'm just going to quickly take that into the first equation, which tells me that y's should look like an x minus a 3, so y is the number 4. So my next answer is x is 7, y is the number 4. So, too many words. A trainload of cars and trucks is being shipped to Crown Motors and Reading. Before the shipment arrives, the accounting department receives an invoice showing that there's a total of 160 vehicles coming, but the part of the invoice that shows how many of each kind of vehicles is lost. Your boss desperately needs to know how many of each kind of cars are coming, cars and trucks, so that they can set this up. So one of my things is I'm going to identify, you know, and our book calls this, write a let statement, right? Let C equal the number of cars, and I'll say let T equal the number of trucks. So I know what I mean by trucks and cars.
So like underline 160 vehicles are arriving,
Mm-hmm.
and then nothing really, and then go down to how many of each kind of cars and trucks are coming.
Okay.
And the rest, you know, I would just go back and see.
Yeah. Can you tell me one of the equations you wrote down?
I wrote 1400 T plus 1000 C.
And what does that equal? 182,000, right? So every single truck weighs 1,400 pounds. Every single car weighs 1,000. These were kilograms. Sorry. So I have, you know, 1,400 T plus 1,000 C equals 182,000. The other equation that we have is that the number of cars plus the number of trucks has to equal 160. Yeah. Now I don't care if you do substitution, elimination. There's, you know, you can use any method you want. Any preference? What did you guys go with? Yeah.
Elimination.
Elimination?
Yeah.
You did? Okay, so if I'm going to do this by elimination, I'm going to tweak this just a little bit. I'm going to say trucks plus cars equals 160 vehicles.
Yeah.
So in order to get this to eliminate, which variable did you eliminate?
We try to eliminate T.
T.
So we multiply T, and we multiply the second equation by negative 1,000. No, wait.
oh, so then-
No, we're trying to get rid of C.
Okay, so you multiply by negative 1,000, that would get rid of, okay. So if I do that, this, let's rewrite the first equation so it's down here. So I've got 1400t plus 1000c equals 182,000. The second equation would become negative 1000t minus 1000c equals, oh my gosh. So that's, is it negative 160,000?
Yep.
And if I combine these, I can see that C is going to be eliminated. There'll be no C's left, and I would have
400C equals 22,000.
equals positive 22,000. So T is what?
55.
So there were 55 trucks. Now that I know that there's 55 trucks, right, I'm going to just plug them. Yeah, absolutely, yeah. So we've got this trucks plus cars equals 160. I know that trucks is 55. So if I subtract 150 from both sides, I get that cars is 105. There are 105 cars in the shipment. Nice. Next question. Look at this. So the distance from the crest of Shasta Dam to the water measures how many feet the lake is from being full. So if I said the distance from the crest was 100 on one day, and the next day the distance from the crest is 50, you can see that the lake is filling up, right? And it's getting fuller and fuller and fuller. As the distance from the crest increases, okay, what does that mean? As the distance from the crest increases, that means the water level is shrinking, right? It's going down, 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 down. There's less and less water. As the distance from the crest increases, the level of the lake decreases, and the miles of shoreline decreases also, because it's shrinking, right? It's a smaller and smaller pool. The time to walk around it goes down. So if the distance from the crest was 0, this is a full Shasta Lake, right? You've got 365 miles of shoreline. If the distance from the crest is 197, you're way down at 147 for the
I thought that was a really small Shasta Lake, and there was a really big shoreline.
Yeah, no, that's miles around it. So let's go ahead and review how we use our calculators to analyze this problem. So I'm going to hit Stat, and I'm going to go to Edit. On mine, you'll see that I've got no values in here at all. It's completely empty. Now I'm going to enter just my distance from the crest values. So I'm going to enter the 0, and then the 62, and then I'm going to enter 127, and then I'm going to enter 132. And if I make an error, say something, then 152, then 162, and then 197. So those are all of my distances from the crest numbers. Now let's enter in the shoreline. So these shoreline numbers are the first one, 365. By the way, the number of days in it, that's weird. Then 295, and then 217, and then 211, and 181, and 175, and finally 147. So I've got these values in here, right? My data's in. Did anyone see an error? I was entering what I was saying I was entering. So the first thing says, give the least square regression line. So we're going to do that. Does this model appear to fit the given data? So let's take a look at it. I'm going to hit Stat. I'm going to go over to Calculate, and I'm going to come up with linear regression because I want the least squares regression line. And when I do that, it gives me the following equation. It says my model will be y equals negative 1. I'm going to write negative 1.5 times x plus b, which is 363.59. So there's my least squares regression line. The next thing we're going to do is I want to visualize this data, and then I'm going to put the line over. So to graph the data, I'm going to first of all make sure there's no other lines in my y equals. It's blank, and I want to go into my stats plot and turn on one plot. So I'm going to turn on plot number 1, and I'm going to go down and make sure it's a scatter plot. So at this point, now I can hit zoom, and I'm going to ask it to zoom to fit the data. So zoom data. Zoom stat. There we go. And that's basically what the data looks like. You guys were asked to plot these points below. Your graph should look pretty much like that. And I set up the scale nicely, so it was pretty easy to plot the data. the next thing I want to do is I want to add this least squares regression line. So I'm just going to say y equals, and I'm going to do the one here. I'm not going to pull it up from the menu. 1.15, negative 1.15x, and then plus 363.59. And we'll press enter there. Now if I hit graph, I can see my data and I can see my least square regression line on top of it. The next thing that it asks me is, what is the correlation coefficient? Now unfortunately my calculator has diagnostics turned off. I can see that because it didn't show me that. So I'm going to quickly review how to turn on diagnostics. So to turn on the diagnostics, it's a matter of hitting second and then going to catalog. And they're all alphabetical. I can just go down until I get to the letter D. Or I can hit alpha and then just press the letter D and it'll jump to my Ds. Then I still have to go down some until I see diagnostics. I'm at diagnostics on, and I press enter to grab that command, and I press enter to execute that command. So it says diagnostics on is done. Now I'm going to ask it to do the linear regression again, so now I have my diagnostic information. So second calc linear regression. Whoops. And when I pull that up, enter, it gives me now my correlation coefficient R is negative 0.9975. I'm going to write all that down. Negative 0.9975. That is a huge correlation coefficient, right? I would say, without a doubt,
0.997.
there's a 0.9975. There is a huge relationship between these two, right? These two variables are very strongly related to each other. As the distance from the crest decreases, it looks like the shoreline. Oh, I'm sorry. As the distance from the crest increases, it looks like the shoreline definitely decreases, right? Just say that again. Yeah, I'll put the graph back up. There it is. Is the correlation coefficient positive or negative? What does this tell you about the relationship between distance from the crest and miles of shoreline? Well, it's negative, and it's negative. And what it tells me is, and I'm going to abbreviate this. I'll say distance from crest, distance from the crest. As the distance from crest increases, then the shoreline decreases, right? So as one of them gets larger, the other one gets smaller. I'm not going to take the time to plot these points. I think that's a pretty simple task. It's just a matter of getting 0, 3, 6, 5. If I was to do one of them, 0, 365, I would say is about, that's 350, somewhere in here is one of my first points, right? And I can see that over on the calculator also. Let's predict how many miles of shoreline Shasta Lake would have if it were 250 feet from the crest. In other words, if this number right here was 250, what would be this number? And I'll just tell you guys, pretty straightforward problem, right? All we're saying is if x is 250, what's y? We have our model, and it says that the y would equal negative 1.15 times that x value, 250, plus the 363.59. So basically, 59. Basically, if I evaluate this expression, it gives me y. Anyone get the y handy? What do you have, Cooper? So I'm going to take, let me get out of the graph. Oops, quit the graph and clear that. So I've got the negative 1.15 times 250 feet from the crest plus 363.59. And when I do that, it gives me 70. Did anyone have that? Okay, so that's from the model. That's from the rounded model. So anywhere in that neighborhood is good. So predict how many miles of shoreline Shasta Lake would have if it were 250 feet from the crest. Based on the model, right, it says that I should have about 76.09, about 76 miles of shoreline. So two quick linear equations solve this first one. Of course, I would apply the distributive property. So we've got the 2 times 3x is 6x's, and then 2 times negative 7 is minus 14, right? Real important to make sure we distribute that 2 So both things sitting inside the parentheses. We also pick up an extra 4x, and that equals 26. So we're looking at 10x minus 14 is 26. 10x would, if I add 14 to both sides, would be 30, 40, right? Which is 26 plus 14. Therefore, x has to equal 4. And if I come back in, a wise thing to do, especially with the calculator, is just plug this value in here and plug that 4 in there and verify that I get 26. Yes. On the other one, option B, I have to say probably what I would do is, I don't like fractions, so I would probably just multiply both sides of this equation by the number 2. If I multiply both sides by the number 2, my left-hand side becomes 2 times the quantity of x plus 3. The right-hand side becomes x plus 18 times 2 over 2. Now, what's nice about that is my fractions cease to exist, right? So on the left-hand side, I could distribute. I have the 2x plus 6, and that equals x plus 18. Therefore, if I subtract x from both sides, right, we've got 1x plus 6 equals 18, and I believe x is equal to 12. Anyone get something different? Yeah, go ahead. Question number 5. So Tyler, did he make a mistake?
Matt found the mistake.
Where was it at?
Yeah.
Where? In what step?
15x. Yeah, that's it.
Okay, so when I go here and I'm adding 5 to both sides, this number should have been 26. Okay, so if that number was 26, right, if 13x equals 26, what's x?
2.
X should have been 2, okay. Let's see, next question, number 6. Supply all missing values for each. The first one, it says it's arithmetic. Now, if this is arithmetic, I can look at this. Can you guys tell me what my common difference is? What am I adding each time? 6. I'm adding a 6. So what's negative 12 plus 6? All right, and what's 6 plus 6? Well, there we go. That's exactly it. By the way, not a requirement of this question. It just said supply the missing values. But could you guys tell me what this equation would be? Y equals what? There is going to be a negative 12 in it, and we're also adding to it, I believe, 6 times x. So it's y equals 6x minus 12. Remember, guys, this is my common difference, right? This is what I'm adding each time, and then this is where I start. I'm starting here. Okay, on the next one, it says this is a geometric sequence. Now, I've got a bad day because I don't have any numbers that are right next to each other. But in 2 steps, I multiply something by something twice, and I get to 50. From 200 to 50, what is my common ratio here? Yes. Yeah, I'm dividing by 2, or I'm multiplying by 1/2. So my common ratio is a half. So 100 or 200 times a half is 100 times a half is 50. What are the rest of the values?
25, 12, 25, and 6.
And 6 1/4. Okay. Now, if I was going to ask you, and I didn't here, but if we were going to write the equation for that, anyone know what it would be?
Y equals 200.
200 times 1/2 to the x power. Yeah, right? This is where we're starting, right? We're starting at 200, and we're multiplying by 1/2 each time. All right, let's go on to next question. Actually, the next page. The 2 triangles shown below are similar to each other. Find the side labeled x. Can anyone give me the ratio that you would write to find x here? Go ahead, Briar. You wrote 3 over 6 equals? Excellent, yeah. There are other ways you can write it. The important thing is that she's going from the small one to the large, and then she went from the small to the large, right? So 3 over 6 equals x over 15. This is a proportion, right? I could multiply both sides by 15 and multiply both sides by 6, but the cross products are equal, although I'm sure someone at CPM would kill me for saying that. But I get 6 times x equals 3 times 15. I'll change over time, promise. I'm not opposed to changing. So I believe that x should equal 3 times 15 over 6. Brian, what did you get for that? What's 3 times 15 over 6? Or what is x? It's a 7.5. Anyone else agree? Great. Next question. Two triangles here. Triangle XAB. Let's see, from X to A to B. Is that congruent to which triangle? From triangle X to D to C. Very good. By the way, what method are those two triangles congruent by?
Side angle.
Side angle side. Definitely we have side angle side there. Yeah, okay, very good. Next. Real quickly, what are the 5 methods we have for establishing that two triangles are congruent?
SSX, ASA, HL, XA.
Oh. You said ASA. HL, and what else? SAS, and we're missing one. And angle side. Very good. Excellent. Okay, next. Now that we reviewed those, we might use a couple of them here. So triangle box is congruent to which triangle? Yeah, BOS to N to G to I. And what's the reason for that congruency? Okay. Hey guys, are these triangles congruent? Do we have any one of our methods up above here? Right, what we're lacking information about what? They never tell us anything about size, so we would say, sorry, not congruent. Right? And they're not congruent because they never tell us anything about the sides. So we got to come back and look at this. I think I should have worded this differently, cluing you into that possibility, but because I didn't all. How about the next one, triangle MIT? Right? And are these legitimately congruent? Side, angle, side.
See, no, but the thing is, you didn't tell us to tell you if they were wrong. You just tried to get.
I know.
To give us a reason why they were congruent.
I got you,
Said we were
Cooper.
doing deduction.
That's why I said I didn't really like that. But let's come to this one though. Is it side angle side? Do I have side angle side here? I only see one pair of congruent sides. Is there a side I'm missing? Well, you told me side angle side that needs. Okay, so there's a side in the middle. They share this side and it's congruent to itself by the reflexive property. So right now, do I have side and then an angle and then a side? Do I have that on the screen?
No side angle.
But side angle, remember, could be two different triangles. So what do I have up here? I don't have angles. Angle side could be two different triangles, right? That's not one of our 5 ways.
We put the bottom.
Why is it HL?
Hypotenuse leg.
Right here, this is a leg, and this is the hypotenuse, right? So because we have and they're right triangles, right? So this is HL, right? If you look at the pattern, there's nothing. I don't have side. I don't have angle side. I don't have side angle side, and I don't have angle side. The only thing I have here is I have congruent hypotenuses. These are congruent hypotenuses, and I have a congruent leg right down the middle. So it's by HL that those are congruent. So if I'm looking at this one, what's one of the great pieces of information I know from one of these points? I know A. In fact, what is A, Sky? So I can start with y equals A. No, but we know A is 6. So y equals 6 times b to the x power. Now, I need to figure out b, right? And to do that, I'm just going to plug in the other point I have. What is the value of y that I'm given? Yeah, 0.048. And then I write the 6, and then the times b. What's the value of x that I have? 3. So what are the 2 things that I need to do right now to figure out what b is?
B by itself, so you divide by 6.
We're going to divide both sides by 6. So I have 0.048 over 6 equals b to the 3rd power. And finally, what am I going to do now to figure out what b is? Except it's not a square root. What root am I going to take? A cube root. So if I take a cube root of this side, right, the cube root of b cubed is b, And b is the cube root of that thing. So did anyone figure out what that expression was? What is b? What is it?
0.2.
Is it 2/10? Okay, 0.2. Did you just run that right now?
Nope.
No, I got.
So yeah, we verified it. B is indeed 0.2. Next. Has a y-intercept of 12 and a multiplier of 0.4. Okay. What's the equation? It's still a times b to the x. Do we know either one of the values a or b? What's b? B is 4. Do we know anything else? So you said b is 4 to the x. Do we know where we're beginning? Yeah, why are we beginning at 12, Maddie? It doesn't say we're beginning at 12. It says it has a y-intercept of 12. Remember what y-intercept means, guys? When you're crossing the y-axis, I don't know what this looks like, but when you're crossing the y-axis, x is 0. So our beginning is 12. So 12 times 4 to the x power. All right, number 12. Each of the situations below can be described using an exponential function. They represent a very small sampling of the situations where quantities grow or decay by a constant percentage over equal periods of time. For each situation, identify the multiplier, the initial value, and write an exponential equation in the form y equals a times b to the x. So a house purchased for $245,000 has an annual appreciation rate of 4%. First of all, what's the initial value? Yeah, 245,000. What's my multiplier? If I have an appreciation of 4%, what am I multiplying by each year? That would be, say it again, River. 1.04, right? It's going up by 4%. Now, if I was told it's depreciating by 4%, what would be my multiplier? 0.96. Excellent, Maddie. And then finally, what's my equation here? Excellent. Thank you. All right, next one. The number of bacteria present in a colony is 300 at noon. Hello, 12 o'clock. And it increases at a rate of 22% per hour. First of all, what's my initial value? 300 of the little bugs. What's my multiplier? Excellent, because it's increasing by 22%. And then what's my equation? Excellent. And then the last one here, a car has an initial value when purchased of $12,250 and it depreciates at 11% per year. What's my initial value? Good. What's my multiplier? 0.89. Very good. It's depreciating, going down. So we're going to look at 1 minus the 0.11, right? 1 minus it. 0.89. And then finally, what's my equation that models this situation? All right, excellent. Equation. Actually, I was just explaining lots of ways we could do this, but I'm going to use the way that Mitchell described in our textbook. He said, look, we've got this equation for find the equation of the line. Oh, this is a line that goes through these points. So if it's a line, my equation is y equals mx plus b. And the method that Mitchell mentioned to us was we can write a system of equations where we plug in x and y, and we build two equations where we're trying to find m and b. So if I was going to do that with this first values of x and y, what would be this the first equation I could write? Yes, m times 2, and I'm going to flip it and write 2m because it freaks me out writing m2. But 2m and then plus what? Oh, plus b, okay. And then what's the other equation I would write? Good. So this is Mitchell's epiphany, right? Now, other ways we can do this, sure, right? We could find the slope first. We could use the formula for finding slope, difference in our y's over difference in x's, and then we could plug that in and figure out what the b is from either point. But I like this method. It seems a lot cleaner to me. If I want to solve this system using elimination, what's probably the easiest thing to do? Yeah, River? That's beautiful, right? We'll be eliminating the value of b, the variable b, So I'm going to multiply this top equation by -1. It becomes -8 equals -2m minus a b. And then below I'll just rewrite this. 24 equals 10m plus b. Right? When I add these, can you guys tell me what this equation becomes? (16 equals 8m), and therefore what is m? Okay, so we know m. Now we just need to figure out what b is, and it doesn't matter which equation I use. I'm going to go ahead and use this second one because it's closest to me. I don't know. So I'm going to use 24 equals, m was 2, I said, so that's 10 times 2 plus b. So it's 4. Very good. Oh, that's plus b. And if I subtract 24 from both sides, b equals 4. Let's see. So now that I know that, right, the thing is it says find the equation. We're asking for an equation. I'm going to write my answer right here. What is my equation? Y equals 2x plus 4. Love it. Yes, sir. So the last question, basically, we've got this set up here. I've got a system, quote unquote, of exponential equations, right? And in fact, if I look at this first one has a start value of 40, and it has a multiplier, and it's, when x is 3, you get 40, and here when x is 8, you get 1280. So that's basically plugging those in. It's all set up. It's just now, can we solve this system? Now, how are we approaching these? What's one of the things we would do first? Go. Oh, and then you're going to add them? That's a problem because this is multiplication. This is not addition or subtraction. That's not going to work out the same way. Go ahead, Dana. Okay, so you're saying divide both sides of this one by b to the third. So I get 40 over b cubed equals a. Okay, and that's what we discussed, right? We now have a valid value for a. This is what a is, according to the first equation. And we can substitute that into the second equation. So this second equation, if I do the substitution, becomes 1,280 equals 40 divided by b cubed times b to the 8th power. Now, I'm going to write this like this, and I think some of you are thinking this. If I was to simplify this right-hand side a little bit, I might write it as 40 times b to the 8th over b cubed. And you guys know we do this all the time, right? b, 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 b. That's b to the 8th, right? b, 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 over b, b, b. What do I get when I simplify that? b to the 5th, right? So this is 40 times b to the 5th power, right? 8 factors of b over 3 factors of b is 5 factors of b, and that equals 1280. Go ahead, what? Thank you. Divide both sides by 40. So we get 1280 over 4. Is that a nice number? What is that number? What? 320? 32 equals b to the 5th. All right, so what's b? How do you get b as 2 from that? Okay, very good. So you described how to use your calculator, right? So, yeah. 2 questions. First here and then Maddie. I want to make sure everyone at home knows what our final answer was. What is the 5th root of 32? So b is equal to 2. So we haven't written our equation, though. We're not done. Stop. We've got 2 minutes. We know b is 2. We need to figure out what a is, right? By the way, this was us talking off camera. Sorry. So I'm going to plug in 2 into this equation. I get that a equals 40 divided by b cubed. 2 cubed is 8. What's 40 divided by 8? 5. Okay. Now, did I find my value of a? Did I find the value of b? Now, it says also write a function in the form y equals a times b to the x. What's the last part of my answer? All right, you guys, you're a great class today. I'll make sure I'll post up all this stuff tonight.